Here's 8.4, number 61. It asks us to use DeMoivre's, I'm going to say it wrong every time, theorem to calculate 5 plus 3i to the 17th. So maybe I can't say the theorem name very well, but it's a great theorem. So I'm going to call this z equals 5 plus 3i, and essentially we're looking for z to the 17th power. And if I do that, then a is 5 and b is 3. So the magnitude of z is going to be the square root of 5 squared plus 3 squared, or the square root of 25 plus 9, or the square root of 34. And our tangent theta is the b over a, which in this case is going to be 3 over 5. So theta would be tangent inverse of 3/5, and that's approximately 0.54. Now, to set this up, the book put this in the exponential formula, Euler's form. So I'm just going to do the same thing. So I'm going to say z equals square root of 34 e to the 0.54i. So if I'm looking for z to the 17th power, that's going to be the square root of 34 to the 17th power, e to the 0.54 times I times the 17. And I end up with this square root of 34 to the 17th is a huge number. It is 1.04129. It goes on a long way. But times 10 to the 13, that's huge. Then times e to the, and the 0.54 times 17, I'd come up with 9.187i. Now, that's beyond the 6.28, which is 2 pi. So I took that 9.187 and subtracted 2 pi, and it gets us down to 2.90. So that our z to the 17th power is going to be 1.04129 times 10 to the 13 times e to the I reduced that down. So down to the 2.9i. My 2 looks kind of funky. So there you go. That's what they're after.